Hello and welcome back to the channel. This is Abhinav. So we have recently launched pro subscription of coding75.com, and later in the video you will see the recording of a demo class of that pro subscription. So we are actually giving first 10 days free access to all the live classes of Coding75 Pro. So this class is a demo class of that particular subscription. Do check it out, and if you have any interest in Coding75, if you have any doubts, any queries related to it, you can contact to me directly using the contact query number given in the description. You can check out, you can contact to me with the WhatsApp number, or you can also check out the coding75.com/pro for others data regarding the pro subscription. Thank you. See the recording.
Hello everyone, welcome to Coding 75 linked list masterclass. So in this class we are going to discuss about this linked list data structure in and out. So we will go step by step. As this is a demo masterclass, so we are not going to discuss any kind of questions here. Rather, simply like as linked list itself is a huge topic. So everything related to linked list, the operations, the advantages, how to create, how to insert, delete, and how to traverse linked list, all of these things we are going to discuss here. So, alright guys, before we begin, let me introduce myself first. I am Priyanshi Porwal and I am an upcoming software engineer apprentice at Autodesk. So, let us begin our masterclass. Alright, so let us begin with knowing what a linked list is. So, linked list is a data structure. Alright. Now, what is a data structure? Data structure is simply a structure which helps us store data. So, in computer science, data structures are used to store data. So, linked list is a data structure. Now, data structures are majorly classified into predefined and abstract data structures. So, linked list comes under abstract data structure. Alright. So, let us understand what is predefined and abstract. I'll just give you an overview about both of these. So, predefined data structures are those data structures which are already available in language, right? For example, in C++, right? If I want to create an array of integer, characters, etc., there is a proper syntax to do that, right? So, I can simply write int array and I can insert some values here, and this is how I create an array in C++. Similarly, if I want to create a string s, so I'll simply write it like this, right? So this is my string, right? So by declaring string, I'm able to create a string variable. By declaring int and with these brackets, I'm declaring a integer array. So these are predefined data structures, which are already, whose syntax is basically already available in a language. But abstract data structures are those data structures which you have to create yourself. So these abstract data structures are a little complex and they're hence not like predefined. Although using C++ STL, these can be like created in a predefined manner because STL contains them, right? If you want to create a linked list, you can simply write list and whatever node value you're going to have, you can put it here. So yeah, there is STL, but apart from that, when we study pure data structures, right? So majorly abstract and predefined data structures are defined. And within abstract data structures, we have linked lists, trees, graphs, stack, queue, etc. So these are abstract data structures. So now we will understand this, the meaning of this abstract, right? Because a linked list is the first abstract data structure that we study about. So we will understand abstract or the meaning of abstract by knowing the definition of a linked list, right? So how do you define a linked list? So the definition of linked list is a collection of nodes, right? So it's similar to array, like array is a collection of items. Rather in linked list, we have a collection of nodes, right? So this node is a structure, right, which has two attributes to it, right? So the first attribute contains data and the second attribute contains the address to the next node. All right. So this basically this structure, right? These two things combined together is called a node, right? So what is the linked list? Linked list is a collection of these nodes. All right. Okay. So as I said, collection of nodes. So this is a linear data structure. So it stores values in a linear fashion, right? Just like your array, right? You have, let's say, you create this array 1, 2, 3, 4. So this is an array. Similarly, The linked list, what will it look like? So as it is a collection of nodes, you have to write 4 nodes here. First node is this, which has a data or value here as 1. Second node contains data as 2. Third node contains data as 3. Fourth node contains data as 4. Now, this particular address field, right, the second attribute in a node actually represents an address, right? Now, how do you represent an address? You represent an address using pointers in C++, right? See, this particular masterclass is going to be in C++ only, right? Whatever things we'll apply practically and in the context of whichever we are talking of is C++, right? So we'll do everything in C++ here. So in C++, we have something called pointers, right? So pointers are variable used to store addresses, all right? So here we use a pointer value. Pointer to what? Another node. So this is pointing to this node. That, let's say this is A node, this is B node, this is C node, and this is D node, right? So A node's next this pointer, right? So we also often call it the next pointer, right? The second parameter of a node structure is often called as the next pointer. So next pointer is pointing to what? The next node here. Similarly, it will point to this node, it will point to this node. So you can see that this is a linear data structure and it is abstract. It is called abstract because it is a collection of node. Now this node is not predefined within your language, right? You have to define it yourself. So now let us discuss how do we define this node? How do we create this node, right? So we will see it practically, right? So before that, again, in C++, how to create something like this. So you can see that node is a collection of two things, right? Combined together. That is data and this pointer to the next node, right? So how do we do that, right? How can we combine two different entities together? So for that, we have something called structure, right? So we use the struct command and then we write the name of the structure, which is in our case node. And then what we simply do is write int data and this pointer value, right? See, structure in C++, let me give you a small example using which you can understand it and why we are using it here. The structure is simply to combine different entities. Let's say we have an entity like a student, right? So instead of using classes and objects, we just have some variables and I want to combine them together, right? So what I'll say struct student, and let's say of student I want to store his name. So string name I'll do. Then let's say I want to store his roll number, so I'll say int roll number I'll do, right? So this way I'm creating this as student structure here, right? And I'm combining these two entities together. So this way we create a structure in C++. We use struct command and we write the name of these structures. This is a syntax to declare a structure. Then we write int data, and here the next thing we want to write is the address, right? Or the pointer. Now pointer to what? The next node. So how am I supposed to write this pointer? So I have to write the pointer as struct node star next, right? So basically the name of the second parameter is next, and this struct node, see, whenever we are declaring pointers, right? So pointers are declared with this star symbol. So let's say if I want to declare address of a integer, right? So I'll say integer star and then I'll write its name. So P, let's say this is. So this is representing that this variable right here is a pointer type and it is pointing to a storage unit which is storing integer data type, right? So here we are writing struct node. This is the address, right? This is the type of the address we are storing and this is the name of the variable, all right? So this is how we create our structure node, right? So this is how you create node. Now I want to create this linked list. So linked list is what? A collection of node, right? So let us go ahead and see this in action, right? Let us write the code for it. Okay, before we begin writing code, let me tell you how to create a linked list, right? We have created the structure. Now how am I supposed to combine it, right? See, there are 3 steps to it, all right? So there are 3 steps to create a linked list, right? So after creating this node structure, so after you're done creating the node structure, the first step is to initialize all the nodes. So currently I have 4 nodes here, A, B, C, D. So first step is to initialize all nodes, right? The second step is to dynamically allocate memory for them. See, whenever we talk about predefined data structures, we basically, whenever we say string S, so as soon as the compiler sees the string, it goes into the memory and it takes out whatever string it is, and it takes out those number of blocks in the memory and number of bytes required to store them, and it stores it in the memory. But in case of having something like a linked list, an abstract data structure, you need to dynamically allocate the memory, right? You have to tell the compiler, all right, I have these nodes. So I have A, B, C, D nodes. So right now, these are not present in the memory. We have just initialized them. We have just declared, okay, we are going to have 4 nodes. But where are they? They have to be stored in the memory, correct? So we have to store them in the memory, we have to dynamically allocate the memory for storing them. So we need to dynamically allocate memory. All right, then the third step is linking them, or basically entering the values for them. So A node contains the data unit as 1, and this next is storing the address of B node, correct? So here B should be stored, here C should be stored, here D should be stored, right? So this way. All right, so we have to basically create the linked list now, right? Basically enter the values of nodes, right? Or node attributes. So this is the 3-step way you create a linked list. Let us go on to the compiler here and let us do this, right? Let me simply write using namespace std here. All right. Now the first step is to create the node structure, right? So how am I supposed to do that? I have to simply write struct, the name of the structure, and whenever we are creating the structure, never forget this semicolon, right? All right, so this way the compiler knows, okay, this is a structure type. So it combines 2 entities together. So first thing we need to pass here is the data. So integer data we are going to store. Then the second one is the next pointer. So we say struct node star. So struct node star. So struct node is the type of value you are going to store, right? That whatever is going to be stored here, what is its type, right? So that we need to know, and its name we will write next, right? So this is the name of this pointer value. All right, so this basically represents that we are pointing to struct node, right? This is the type of address we are pointing to, right? Type of the whatever is stored there, what type it has, that is we are storing here, and star represent, it is a pointer, it is going to store the address for that, and next is the name of this pointer. All right, so now we are done creating the node. Now what we have to do is we have to follow the 3-step strategy to create a linked list, right? So let us write step by step. So first thing is initialization of the nodes. How do we initialize them? So first we need to create these nodes, right? We'll say struct node star A, and everything will be null initially, and this way we will be creating 4 nodes. This is B, this is C, and this is D. And after this, so this is the first step, initialization. Now the second step, right? We have to dynamically allocate the memory. Now, how do you dynamically allocate the memory in C++? There is a function called malloc. You must have heard it while you were, in your university or your when you were studying C++, right? So malloc function is used to dynamically allocate the memory, right? So what is the syntax for that? First of all, you have to write the node, right, for which you are allocating the memory. For A, you are allocating, right? So first you pass in the type, right? So the type is a pointer value of type struct node. Then you write the malloc function, and inside the malloc function you pass the size, basically how many units of memory you are going to occupy. So using the size of function and the type, let's say if A was an integer and you were dynamically allocating memory for it, you would have write int star here and malloc size of int. Okay, so here we need to write struct node. So this will dynamically allocate the memory. Now let me copy this for all the 4 nodes, right? Because for all the 4 nodes, we want to dynamically allocate the memory. All right. So we have dynamically allocated the memory. All right. So second step is done. Now the third step is to combine or basically enter the values, right? So we have two entities here, data as well as the next pointer. So we have to put the values for A, like what is the data in A and the next pointer in A. What is the data in B, next pointer in B, and so on, right? So let us start with the A node. So A node, A of data is going to be equal to 1. A of next, as we saw, was equal to B. Then B of data will be equal to 2 and B of next will be equal to C, right? Then C of data will be equal to 3. C of next will be equal to D, right? And then D of data will be equal to 4. Now what will D of next contain? See, in a linked list, the last node always points to null, right? So null basically is a value that, okay, we are now, this is because this is the last node, we have no more nodes further, so we simply pass in null here. So null can be written as null ptr or in capital null, right? So this is two ways you can write it. You can also write it like this, null. All right, so both of these are basically doing a null. So null ptr basically means a null pointer. It has no value. So we have simply created our linked list here. So it looks something like this. All right, it looks something like this, right? So this structure we have just created here, right? So A node, B node, C node, D node. So now the D node, as we saw, it points to null. All right, so now let us see two important things in our linked list. So after we have created it, right? So the very first node in the linked list is always called as head and the last node always points to null. So these are two things about a linked list. All right, so I hope that is clear to you. How do we create a linked list? So we also have wrote a program for that. All right, now let us go ahead and see, first of all, like before we discuss the types of linked list as well as what are the operations we perform on linked list, I want to tell you why we have a data structure called linked list, right? Why does a linked list data structure exist, right? So basically, advantages of having a linked list, right? Basically, why we have a linked list. Okay, so the very first advantage is, see, linked list is also a linear data structure and it also store collection of nodes. Array is also similar. It also store collection of items and it is also a linear data structure. So what is the difference? Why do we use a linked list then, right? Because it's a complex way of doing things, right? As you can see, in case of array, we don't have to do all these things, right? No initialization, no dynamically allocation of the memory, no binding the data like this. So why do we use a linked list? See, whenever we declare an array, right? So what happens in the memory is we have to take contiguous unit of memory, right? So if you have a very large array, you are going to actually require a lot of blocks of contiguous memory. Contiguous, remember, in continuous blocks, right? You require that particular block to store an array, right? But in case of linked list, you can see why we are storing the next pointer and why we are dynamically allocating. So when you are creating a node, when you are dynamically allocating it, let's say it gets stored here. Then you have B node stored somewhere here. Let's say C node stored somewhere here. D node stored somewhere here. So you can see they are not in a contiguous manner. So this is the first advantage, right? Over an array. Because in array, let's say you have consumed a lot of memory of yours, right? Now you want to create a very large array. You will not be able to. But using a linked list, you will be able to efficiently utilize memory, right? Because you have a node. Now it is also a sequential data structure. It is also linear. But you know, after a B comes, by accessing the second unit, right? The pointer value. Here you are going to have C. Here you are going to have D. And this is null. So this basically represents this is the last node. You can see that B is here. Go to C, C is here. Go to D is here. All right. So you have basically linked it. So this is the very first advantage of having a linked list. Second advantage is linked list is a building block for rest of the data structures, abstract data structures, right? For example, graphs, trees, stacks, and queues, right? For them, we basically, usually for stack and queue, we use a linked list, right? Now, let us understand why do we use a linked list, right? One of the other major things, right? It is because everything we do in a linked list is in constant time, all right? So whether it's insertion or whether it's deletion, right? We do it in constant time, all right? So, for example, you must be aware of what a stack data structure is. Let me tell you if you don't know. Stack is something which follows like book, right? Let's talk about books. How books are stored. Books are stored like this in stack, right? So on this book is, let's say, one book that is laying on the bottom, and then we have next, and then so we have like stacked these books, right? So just like these books are stacked, we have this stack data structure. So this follows LIFO order, last in first out. Basically everything is, see, whenever I want to remove a book from this stack, I will remove the top one first. Whenever I want to put a book, I will insert it on the top. I'll put it on the top. Similarly, in the stack, everything you do, either insertion or deletion, you do it from the top of the stack, right? Similarly, in a queue is something like this, right? So you insert in the last and you take out from the first value. You can see that you do this in constant time because you have an access to this and you have an access to this. Similarly, in the stack, you have the access to the top and you do it in constant time. While in array, you have to do it in, whether it is you want to insert, whether it is you want to delete. The worst time complexity is because of in linear time complexity, right? So this is the third advantage of using a linked list, right? Usually linked lists are used for this. All right, so I hope now you understand the advantages of linked list. Let us discuss what are the types of, okay, before we discuss the types, let us discuss what are the operations we perform on a linked list. All right, operations performed on a linked list. Okay, so whenever we talk about any data structure, there are four major things or four major operations that we perform. All right, so the very first one is insertion. Second one is deletion, right? So whenever we have a new item, new node, how do we insert it? How do we delete it? Third one is searching. How do we search for a node, right? Within whether a particular value node exists in the linked list, right? So searching. Fourth one is traversal, right? Basically, I want to see all the values in the within the linked list. How am I supposed to? I traverse the linked list. So traversal of a data structure means whatever values are stored in that data structure, I want to output them all, right? So that is how you traverse the data structure, right? What it means to traverse a data structure. All right. So let us begin with the very this one, that is traversal. How do we traverse a linked list? All right. Let us see how we traverse a linked list. All right. Let me draw the linked list that we just had here. And this is null. All right. So just after doing the practical of creating a linked list, I told you that the very first node in a linked list is the head node. And the next one is that the last node always points to null. Last node's next pointer always points to null. So these are two important things to keep in check, right? Or to keep in notice, right? So using this, we will be able to traverse this linked list. All right. So this is A, this is B, this is C, this is D. So my output should be 1, 2, 3, and 4 on the screen. This is what I want to print. How am I supposed to do that? Right? So as I said, the head node is the very first node, right? So in a linked list, head is way of much importance because only by using the head node we will be able to access rest of the nodes in the linked list, right? So if I know what the head node is, I'll be able to easily traverse the linked list because only after head nodes do we have these next pointers which link or which make the sequence to the other nodes. All right. So we have this head pointer. So what we basically do is, let's say we make a new node current and we make it point to the head node. So basically we have made this as the current node. All right. So this is my head and my current node is currently pointing to this node. Now what I'll do is I'll simply write a while loop, right? And I will say keep looping through until this current doesn't become equal to null, right? As soon as it does become equal to null, I have to stop iterating. All right. Now within this while loop, what am I supposed to do? So I know my current is right now at the head. So first thing is to see out whatever this node is, right? So see out basically data of current node, the data of the current node. And then as I know this next pointer, right, I can say make current equal to current of next, right? What does this line mean? See, this is an assignment operation. So what I'm doing is I am assigning the value of current of next. So current of next is actually B node, right? So this current, how am I supposed to go on and access the next node? This is how I do. I say current this, go and point to current of next, which is this one. So what it will do is my current will be moved here, right? Because here we are accessing the next current of next, which is pointing to this node. So this is how I am accessing it. All right. So this way I'll keep moving forward. So I'll say current of pointed to next. So this is I move one node by one node. All right. So now my current is here. I'll print this value. Then again, after this step, I'll move next to the next node. So now my current is here. Similarly, I'll print its value because while current is not equal to null, we have to loop through. So current is currently not null, right? So we'll see out whatever the value is, we'll get 3 and then we will move to the next node by using this line. So here we'll come to current and then we will print its value and then again move to the next node. Now next is null, right? So when now current value is actually here. And as soon as I come to this condition, while current is not equal to null, you can see current now is null basically. So this condition became false and I can exit this loop, right? So this way we can traverse a linked list, right? So I hope you are getting it. Let us go onto the compiler and test this out, right? So first thing is I'll create the head node, right? So the head node is a node. All right. Now what I'll do is I'll create the current node which will be equal to my head node. All right, and I have to put this while loop and I'll say current while current is not equal to null. We have to do two things, two steps here. First thing is to see out current of data, right? And let me put this space so that we can see each and every node. And then current should be equal to current of next, right? So this way we will be able to traverse the linked list. Let us see. So we have gotten 1, 2, 3, 4, right? So which is what we had actually made, right? So our linked list was supposed to start from 1 and sequentially it had 2, 3, 4. So we are able to see that now. All right. You can also put something like this here, these arrows, right? And then you'll be able to view it like a linked list. You can see this now, right? So this is how you can basically traverse a linked list, right? So I hope this is clear to you. Now let us discuss the time complexity for the traversal. So the traversal of a linked list takes linear time. So n being the number of nodes here, big O of n time, because if n are the number of nodes, we will iterate here n number of times. N steps will be taken. So the time complexity becomes big O of n, right? So this is about traversing a linked list. Now let us move on to the first operation, that is insertion in a linked list. All right. Let us see insertion in a linked list. See, why the reason I told you traversal first is when we will insert, we can view like what values we have inserted, where we have inserted, and that we can only know by traversing the linked list, right? So that was my motive of telling traversal first. Now let us see how to insert in a linked list, right? How to perform insertion in a linked list. So insertion can be done at the start, at the end, or anywhere else, anywhere in mid of the linked list, right? So these are the three places you can insert, right? So let us first see how to insert in the starting of the linked list. All right. So right now my linked list looks like this. We have 2 here, we have 3 here, and we have 4 here. Now this is my head node. Okay, this is my head node. Now I have another node which has a value of 0. right? This is my D node and I want to insert it in the beginning. I want to insert it here, right? D node. I have 0 here. So how am I supposed to insert it here? What I'll do is simply, I have this D node, right? First of all, I will have to create it first, again initialize, then dynamically allocate, and then the third step is insert, right? So how am I supposed to insert it? See, in linked list, two things are very important. That is this data point and the next pointer, right? So while inserting, I want to basically do what? I have to insert it here in the beginning. So what I'll do is to insert it, its next pointer, I will point to the head node. And my head node I will make equal to D. My head will become equal to D. So now I have successfully inserted in the beginning of the linked list, right? So it is not a rocket science. It is quite easy to understand, I guess, that you wanted to insert in the beginning, right? So in the beginning, you always have a head node. So what you have to change? First of all, create the new node, right? After you create the new node, make it point to the head node. Then make the new node as the head node, right? So this way you can insert in the start of the linked list. So let us do it here. Let me create, all right. So D node already exists. We have to create an E node here, all right. So we'll have this and okay, let me create it after this. All right. And then I will dynamically allocate the memory for it. So this is going to be E node. I'll dynamically allocate the memory for the E node. And then I have to make the E data equal to 0. And E of next, to insert it in the beginning, I have to make it equal to whatever is the head node. Then I have to make the new head node as the what? Current node, right? This new node that I have created, E. All right. So now this current has to be present here to traverse it. All right. Let us run it. So you can see 0 has been inserted in the start of the linked list. So this is how you insert in the beginning of a linked list. Alright, so I hope that is clear. So see, to insert it in the beginning, the time complexity taken here is big O of 1. Alright, now let us see how to insert in the end, right? So I will not go ahead and explain you here. I'll rather explain end and anywhere in here only. Okay, so let us see how to insert in the end. I'm only going to explain you the logic. How do we do it, right? Alright, so now my linked list is, let's say this node, this E node only, I have to insert in the end, right? Not here. So my original linked list was this, right? We have 3 and we have 4 and null. All right. Now I want to insert this new node here, right? Let's say it's 5. Okay. So the first thing after we create this node, see, because this is now going to be in the last, I know for a linked list, the last node is what? Always null. All right. It's always null. So first thing is I will make its next pointer equal to null. Now, as this is the last node and this is the second last node. So what I have to do is, second change I have to do is I have to link it with this, right? So basically of the original linked list, I need to access the last node of the original one, right? So how am I supposed to access the last node? So see, when we did this traversal here, right, we have to simply do this, but we have to just make a small change. Instead of writing current not equal to null pointer, I'll write current of next is not equal to null pointer. So what do I mean? So I'm saying we will loop through while current of next is not equal to null. All right. And by the end of this iteration, I'm saying that in my current, right, I will be storing the value of the last node or the pointer to the last node. So let us see. Let us do a dry run. So this is my current node initially, right? So I will check if current of next is not equal to null, then move. Current of next is this one, it's not null, move. All right. So again, see for current of next. Current of next is this. Is it null? No, it's not null. Move here. Now again, see current of next, not null, right? So current of next is not null. So you will move here. After this, check if current of next for this node is not null, but here it's null. So we'll stop. So now you can see my current node is at the last node, right? So now what I can do is I have accessed the last node. So of last node, I have to make a connection to this newly node that we created. So this is E. So I'll say current of next now should be equal to E, right? So this way, this node can be inserted in the end, all right? So this is how you insert in the end. Now, to insert anywhere in between the linked list, let us see how we are supposed to do it. Let's say I have to do it after the second position. So I need to go and check what is the second node that we have. So let's say I have 1, I have 2, and I have 3, I have 4, all right? And this is null. And I want to insert this freshly created node, let's say 5 values present here in between, right? So what basically I have to do is I have to insert it here after the second node. So I have to first reach the second node here, right? So just following this logic we can do, but instead of having a while loop, we have to put a for loop. So for, we will iterate in it 2 times. So number of position times, right? So I need to get the second node. So actually less than n times we have to iterate in for loop starting from 1. And then I will be doing again current is equal to current of next, right? So with that, my current after this for loop will be standing at this position, right? Then all I have to do is I have to make, see, I have accessed this. This is my current. So I have to do 2 things here. First of all, I have to make its next pointer point to this node. So how am I supposed to get this? So I have this as my current node, right? So current of next represents this node in the original linked list, right? So I'll take a, let's say, temporary node, and in it I'll store current of next node, right? All right. Then what I'll do is I'll make current of next, because this, we have to break this link and we have to point here, right, to the newly created node, which is E. So I'll say current of next should now point to E, right? And then E of next, where should it point? It should point to temp, which is the current of next node, right? So this way we have to point it here. So inside of temp, this value is stored, right? So this way we will be able to insert in anywhere in between the node, all right? So this is how we basically perform insertion in a linked list, all right? So I hope I was able to make that clear to you. Now let us go ahead and see the third operation, right? That is deletion, all right? So how do we delete from a linked list? Again, just like insertion, you can delete from the start, you can delete from the end of the linked list, or you can delete any value within between, right, in between the linked list, right, anywhere in mid, all right? Okay, so if I have to remove from the start, right, so the very first node I'm talking of removing, this is my original linked list, right? This is 4, this is 3, this is 2, this is 1, and this is pointing to null, right? Now I have to remove this node, right? So this is what? This is the head node, right? So all I have to do is I have to make head node point to the next node, head of next, right? So head of next is the second node. So how do you access the second node? You just take this pointer out, that is whatever is this pointer pointing to is my second node. So it is head of next. So just make head equal to head of next. So this is my new head. So head obviously is the first node of our linked list. So I'll point to head now, all right? So head is equal to head of next. This way we can simply remove from the start of the linked list, right? So I hope this is clear, right? So again, here we are going to discuss the logic because we've already understood. I'm already writing the code also here. You have to simply write it there, right? Because I've explained you how to create a node, how to traverse a linked list, etc. All right. So I hope I was also able to make this clear. Now let us see how do we delete from the end. Okay. All right. So again, let me draw the original linked list that we had created. And this is pointing to null. This is 4, 3, 2, and 1. And this is my head node. Now I want to remove this node, right? So to remove this node, this will, after removing this node, just see what will happen. This will become my last node, correct? So if this has to become my last node, its next pointer should point to null, correct? That is how we identify which is the last node in a linked list. All right. So we have to make it point to what? Null. All right. So how am I supposed to do that? So the first step is to access the second last node. right? So how do you access second last node? Again, just like we did here, right? While current of next is not equal to, this was to get the last node, right? I want to get the second last node, so you just have to make one change, that is current of next, correct? Let us see here, right? So we are saying while current of next is not equal to null, right? Let us see how we will get the second last node here. So this is the head node, right? Current is initially here. Check current of next. This node, is it null? No. So move your current. After you move the current pointer, again check the same thing. Current of next of next. So this is next and its next is this one. Is it null? No. Move your current. So your current is here. As soon as you come here, you can see current of next is this and its next is null. So you will fail this condition and you will exit this loop. So now you can see that after this iteration, your current will be storing the second last node. So now as you have the access to the second last node, just make its pointer point to null, and this way you will be able to delete the last node from the linked list, right? So I hope this is also clear. How do you delete from the start? How do you delete from the end? And this is your homework, how to delete anywhere from the middle of the linked list, because we already see how to insert anywhere in middle of the linked list. So it's kind of similar and actually easier, right, to delete from anywhere in between the linked list. So I hope all these operations are now clear to you, right? These operations that are performed on a linked list. Now, the last thing that we are going to discuss in this master class is types of linked list. Okay, types of linked list. All right. So the linked list that we were now looking at is a singly linked list, right? So a singly linked list has only two parameters, right, within its node. First one is the data and second one is the next pointer. All right. So it points like this. This is your singly linked list. Second type of linked list you have is a doubly linked list. All right. So doubly linked list contains three attributes. All right. So this one is the previous pointer, this one is the data, and this one is the next pointer. So basically in doubly linked list, you can access the linked list moving forward or moving backward, right? So let me draw a linked list for you. The linked list that we had drawn here, right? Let me draw it. So this is 1, next node is, this is 2, next one is 3, and the next one is 4, right? And this will be equal to null. Now, this points to the previous node. 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 And this points to null. So this is what your doubly linked list looks like. So using these previous and next, wherever you are in the linked list, you can move to the previous node or you can move to the next node using previous and next pointers. Inside of singly linked list, you only have the facility to move towards the next or in forward fashion in a linked list because you don't have access to the previous pointers, right? But in a doubly linked list, you can achieve that. The third type of linked list is a circular linked list, right? Now, circular linked list could be singly or doubly. So basically in circular linked list, what happens is in the last node, instead of pointing to null, it points to the first node, right? So it becomes a circular linked list. Similarly, what a doubly circular linked list would be, this null pointer will be actually pointing to this node and this previous pointer will be pointing to the last node, right? So this is what a circular doubly linked list is. So circular linked list. So these are the types of linked list we have. So again, we have these linked lists for some purpose. So doubly linked list and circular linked list, they have their use cases and applications, but most of the times singly linked list is used. All right. So I think now I have covered everything, right? Whatever was the agenda of today's masterclass. So yeah, I think everything is to you now clear, right? Whatever we discussed, how we create a linked list, how we insert in it, how we delete from it, as well as how we traverse it, right? And what are the different kinds of linked lists that we have, and what are the advantages of linked list. So yeah, that was about the session. Now let's end the session. But before that, Let me tell you about Coding 75 again, but because you are here, you already know about it or you have already heard about it. But let me explain it to you again. So Coding 75 is an all-round platform. So it is like one and all platform where you can prepare for your interviews as well as online assessments, because we provide contest discussions for free, right? So contest solutions are free, whether it's Leetcode, whether it's Codeforces, whether it's Codechef. Similarly, we also have solutions to Leetcode daily challenges. All of this is free, right? This is free content. Along with that, we have CS fundamentals notes, right? Very well curated and in depth, right? And all the very important topics that are asked in interviews are covered in it, right? So basically, everything related to your interviews and all of these resources that I'm telling you, the resume builder, these contest solutions, the daily challenges solutions, right? All of them are available for free on the site. And along with that, we also have a pro batch. So in just 500, you will be able to get access to resume review sessions, personalized guidance, one-on-one sessions, as well as live sessions for development as well as DSA. So in the market, I think there is no other platform which is providing all of these facilities as cheap as this. So I think it is a golden opportunity that you should not miss, right? So, yeah, that was all about Coding 75, and thank you for attending this masterclass.